Hello everyone and welcome to the very first episode of the World Cement podcast. My name is David Bisley, Senior Editor of World Cement, and I'll be your host over the coming episodes. Over the following weeks, we're going to be talking to experts from across the industry to get their thoughts on some of the key topics facing cement producers in the 21st century. For our first two episodes, however, we're going to be taking a look back. Specifically, back to March 2024 and the closing panel discussion held at EnviroTech Lisbon, which focused almost entirely on the topic of carbon capture. With the 2025 edition of EnviroTech coming up very soon, this seemed like a good opportunity to take stock and consider whether the thoughts and discussions raised a year ago still apply today. Or perhaps new challenges and new opportunities have emerged since. So, sit back and settle into the first half of our CCUS panel discussion, featuring insights and wisdom from Nate Lozanoski of Honeywell UOP, Burcin Mckenna from Ramboll, Paul Monaghan from Mannok, and Angela Nunes of SECIL. Thank you. I just wanted to take a moment to remind you to register for World Cement. It's free of charge and gives you access to the latest issues of World Cement, both in print and online. Every issue comes packed full of regional analysis, technical articles, project case studies, and the latest industry news. Simply head over to worldcement.com, click the magazine tab, and register today. It's as simple as that. Happy reading. Thank you so much for joining me today. And I know we've got a whole list of topics to get through, but we're going to kick off with a topic that has come up almost unprompted, almost every single Q&A session, which of course is carbon capture. So to start off with you, Nate, what would you say currently, from your perspective, is the biggest challenge to implementing carbon capture across the cement industry?
Yeah, so just maybe a quick 2-second introduction. So Nate Lozanoski from Honeywell UOP, we're a carbon capture technology licensor. We've traditionally played in the oil and gas space for about 100 years. And when it comes to different types of carbon capture technologies that we offer, as you described, there's multiple ones in the market through your presentation. We have hot potassium carbonate, first and second generation amine technologies, pressure swing adsorption, cryogenics, and then any combination of those that we would be able to supply to the market. So when we think about being technology agnostic, even as a technology licensor, I would say we bring a pretty agnostic view to finding a solution that works right for each cement plant. So when you talk about what are some of the challenges outside of the pipeline, the regulatory environment, and finding projects that work, is really getting into the site-specific conditions. Every site's going to have different utility pricing, utility availabilities, plot space, CO2 concentrations, CO2 purities for whether it's going into a pipeline, methanol production onto sustainable aviation fuel. When you talk about the challenges, it's really getting into those site details and understanding it. And I don't think there's necessarily a one solution fits all for the cement industry. There are going to be certain technologies that are more attractive at different sites than others because of all those conditions.
Okay, thank you, Nate. Burcin, I saw you nodding along. Would you like to add anything to Nate's comments there?
I completely agree with Nathan. When I say it really depends on the site, and then that sounds like a very typical consulting answer, but it really is in this case. And considering those utilities and what are the heat recovery options, do you need to do everything on renewable electricity? Or do you have access to biomass or biogas? All of these are different parts of the puzzle that's going to influence your CapEx and OpEx.
Thank you. And Angela, I see you nodding along. Do you have anything to add to that?
Yeah, maybe from the point of view of the cement producers, for us it's a quite new process. So our focus is to produce cement, and this is something completely new, out of the box. So something aside or something that must be integrated in our new process. The first question for us is when we should be able to start this, because we heard about so many technologies, but some of them, they are not really set or ready to be installed. And this is one of the question marks that we have. Another one is the need for infrastructures, because, for instance, in Portugal, there is a huge need from the grid, the power we have available in the grid, especially renewable energy, is not enough for these consumptions. This is the truth in so many points in the country. Then you have the infrastructure needed for CO2. So there are a lot of needs that need to be assessed to get everything ready on time. So the right time, the right technology, and the infrastructure for us is our main concerns.
Okay. And Paul, from your position at Mannok, does what the others are saying ring true? Does that echo with you?
Many, many challenges, yeah, because at a macro level, you have the cement producers in Ireland that basically there's an excess in the market. So the excess needs to go somewhere, and it normally goes into, for us, it's the UK market, so for others, it's the UK-European market. We see that other UK and European situations are more advanced than us, and potentially what that does is give others a competitive advantage. Logistically, we're probably the most challenged cement factory on the island. We're 90 to 100 miles away from the nearest port. So that really does exercise us, given the fact that we're the most important regional employer, where we are about the future. So really what we're talking about is the future of the industry and the future employment opportunities. Then if we bring it down to the micro level in terms of a carbon capture technology, for Mannok, we take a very step-by-step approach, knowing really that the policy and the supports and infrastructure are at least several years away. This is just the reality for us. I understand from other presentations and with the EU innovation funding, and if that funding is available, I understand they will pick the most mature technology, and it's a major problem for the industry. So if they have the opportunity to capture large scale and put it into permanent storage, I understand that. We would take a slightly different view, I suppose, maybe being both a cement and a concrete and building products manufacturer. We are going to look to demonstrate a number of smaller demonstration projects, maybe focusing on carbon curing and mineral carbonization, and prove them out so we can focus on the utilization. And on that, I just want to say, really, I think the industry has a responsibility, given the fact that it's going to take very, very significant public funding to decarbonize the cement industry, and particularly in the carbon capture area. So I think there's a kind of a responsibility on the industry to help develop those utilization opportunities. And we will need help from maybe in people in the room to help identify those and deliver on them. But and that number might only be 5% of the total, or whatever that number is. The number for me is not really important. It's the fact that we demonstrate in good faith that we're good neighbors and that we're part of the solution. And yes, the storage, when it becomes available, and there's very little available in the world at the moment, okay, that is being developed, then that will come and we'll be ready. But we would like to show also some leadership in carbon capture in the market that we're located in. And we would like to do a number of small demonstration or pilot projects to demonstrate our good faith.
Yeah, thank you. And back to you, Nate. A lot of the roadmaps for achieving net zero have this deadline at sort of 2050. In terms of the technology readiness level of carbon capture, are we on track to meet those deadlines? Because by all estimates, carbon capture is going to be doing a lot of the heavy lifting of getting us to net zero.
Yeah, so I think each technology, at least in the oil and gas space, has been demonstrated for a long time. I think you alluded to it, especially in the amine space. And it's really identifying those critical differences of taking that technology from, say, hydrogen purification for a PSA, and what are the challenges that are operating in a CO2 PSA space. Or I'm using cryogenic fractionation to liquefy the CO2. What are some of the constituents that could be limiting in that technology? And we see all the technologies that we have available as TRL9 because they've been demonstrated in other industries. But typically when you go to gather funding from somebody such as a government, right, they want you to critically identify those changes and what are your mitigation plans and how do you engineer solutions, whether it's on the pretreatment coming into the unit or how do you engineer solutions within the cryogenic unit to, say, handle NOx per se, right? And I think the other thing that when it comes to technology readiness levels and deploying these technologies is you're putting all this capital and expenditure just to capture CO2. The other thing they typically look for is how can you mitigate those other hazardous pollutants that are coming out of the stack today and also find a way to neutralize and prevent them from entering the atmosphere as well.
Thank you. So Burcin, I direct the same question to you. Where are we on the path to net zero?
Considering 2050 goals, I think we are on a very good track. Technology development takes time, of course. You can't just bring something in a year to the market. And even if you would do that, you wouldn't be able to find anyone willing to be the first demonstrator on that. There are a lot of funding opportunities for the new technologies development. And I think those are really good initiatives. Like in US, DOE has a lot of scale-up funding, and also in Europe, EU Innovation Fund cares about the innovativeness, the degree of that in applications. And there are a lot of startup companies coming into the play. So all of these will, of course, eventually contribute to the decrease in the costs by the time we reach to that point. But we also need to see the willingness from the emitters to be able to go ahead and test and understand what it looks like. It's very easy to put a slipstream application on a plant. That will not necessarily disturb how the plant operates, but you'll be able to get so much information and knowledge out of those tests.
Okay, thank you. Paul, you briefly touched on some of the ways in which you're looking at dealing with carbon capture in the future. So could you outline a bit more what are your plans for carbon capture?
Yeah, well, I suppose it's one of the pathways that we've identified to decarbonize even for interim targets by 2030. So what I would like to see us doing is capture probably somewhere between maybe 50 to 60,000 tons, but to do that in an innovative way. And I think that's important too as well, because we find, if you want to say, those funding opportunities to help de-risk some of the projects and some of your decisions are available if you work with other innovative startups, OEM suppliers, and so on like that. So, I mean, we have looked at, you talk about carbon capture technologies, and we've heard about obviously the most mature, which is the amine one. We're also looking at maybe what's coming behind that. And we've looked at some of the non-amine options. We've looked at some of the MOF technologies, some people that are associated with the GCCA and the Innovandi project, R&D project that they have there too as well. So I suppose we're very much in the kind of exploration kind of phase. Certainly we do see opportunities and things with a reasonably good TRL level, particularly around the mineral carbonization and what to do with the flue dust on the bypass from a cement factory too as well. And I think the curing and the mineral carbonization will be early opportunities in the near years, even over the next few years. And I'd hope maybe we'll maybe have something to report back, David, on that too as well. Yeah, and I think that's just really important for us to just really learn, allow the technologies to mature until we have to do the really scale up big carbon capture projects at scale from the sluice stack when you're capturing hundreds of thousands of tons and looking then. And of course, once you capture the carbon, of course, you capture it, you have to do something with it. So what are you going to do with it? So if all the carbon was captured from cement factories in Europe, never mind the world, you really wouldn't have anywhere to put it today. That whole market, the whole supply chain has to develop all the way along the line. But again, that step-by-step, David, approach that we want to take. But I think we will be able to deliver some demonstration projects over the next few years.
Okay, thank you. And Angela, you mentioned yesterday in your presentation that you were looking at carbon capture as part 2 of your CCL project. What are your end goals when it comes to carbon capture? What technologies are you looking at? How are you planning to take things forward?
As I explained yesterday, first things first. So we need to be optimized. We need to get the right efficiency in terms of energy and CO2 emissions, and then go into capture as a level that's what is the minimum emissions that we can get from cement kiln. And so that should be the level, the minimum ones. No, the minimum needed is because the amount of energy, there is also a carbon footprint for the capture itself. So by the end of the day, we need to analyze all this cycle, the complete cycle. So balancing all this, we are looking for the most available technologies, but keeping in mind the new ones that can make sense. It's a very challenging moment because you can imagine our own process, we will optimize, but there are also upcoming technologies from the cement side. We heard about oxy-fuel, and there are others, electrification. There are others on the table. So it's too many things on the same time.
Right.
We need some more time to react. That's the truth. So right now, for acting, we need to optimize, get efficiency, putting ourselves at the lowest level of CO2 emission. But the next step, we still need some time to figure out the best way for each plant. Because as we said before, you may have a plant with some infrastructure that will use some available mines or whatever, but you have other plants where this is not the best option. And you should study all these together. So we need some time for that because it's too much things happen very quickly. And that question mark that I told before, it's still also on the table. So it's important for us to have a little bit more some time, but we are really aware that, and according our roadmap, you've seen that it's really needed carbon capture. No way to avoid it. That's clear. Then what to do with the CO2, it's another thing. If you have the infrastructure, maybe it's easy for you just to store it. But if you don't, maybe you need to think on utilization. And so all these projects in our value chain on concrete carbonation and so on may be also very useful. So we are looking to all of these opportunities and balancing them. And for that, we need this time that I mentioned before. So.
Right.
And I would say I would completely agree with that. If you're a cement manufacturer, you have to do what's in front of you. So the main priority is the fuel switching. It's substituting out the fossil fuels to decarbonize. So it's taking out really that 1/3. And I suppose that people in the audience will realize that too as well, is that when you're decarbonizing the cement manufacturing process too as well, is what's going to be that thing at the end. So if you use alternative fuels that are locally sourced, whether it's SRF or RDF or whatever it is, it's very hard to displace that last piece of fossil fuel. It's very hard. So you need something else. So is that oxy-fueling? Is it green hydrogen? Is it biomass? Is it some combination of that? So that's a puzzle that needs to be solved maybe before then, and allow the time for the supply chain to become in place for large-scale carbon capture, because we cannot do everything by 2030, but we can certainly start the journey.
And thank you. Now, obviously, the topic of the issues around storage specifically have come. So, Nate, I wondered if you had any thoughts on how we solve some of the challenges around storing the carbon that we've captured.
Yeah, so I mean, you touched on it, right? There's starting with mineralization, which is a pretty good option for the cement industry because you're going to make more product and utilize your CO2, and it's a really elegant solution in that sense. From a storage perspective, at least in the United States, the EPA issued their first Class 6 well permit in over 10 years for a project we're supporting in blue ammonia. It's a good indication in the US that, listen, they realize that the permitting process needs to be revamped and they're working on accelerating it. The same thing in Europe. They realize that permitting and infrastructure is a challenge to seeing these projects move forward. You can study the technologies all you want, but without a place to put the CO2 for the most part, projects might come to a stall. The next question obviously comes utilization. Where can I store it in a utilized manner? We think about CO2 as being a more or less completely spent molecule, right? And so anything you're doing today, you're putting more energy back into it to make it into a useful molecule. And until you have excess green energy in order to do something like that, on a life cycle basis, you're actually doing worse for the environment by putting all that energy to convert the CO2 molecule to something. We do offer, methanol to SAF, and that's something the EU, is mandating. And the EU, the RED II guidelines are coming into place on when you can use, let's call it post-combustion emissions for those sort of things. But I think, it's certainly an industry challenge, but I think governments are realizing the permitting process for storage. And we at Honeywell are also continuing to innovate ways that we can take CO2 and make it usable again, whether it's dry reforming, more efficient methanol process, things like that, to be able to find another home for CO2 where there isn't the infrastructure today.
Okay, thank you. And Burcin as well, are you seeing any other novel and innovative solutions come up for tackling the issues of storage and utilization as well?
I think, mineralization is probably the most innovative case here, although it's very limited amount of CO2 you can also convert at a cement plant to minerals. So if you have the capture and converting, let's say 10 to 20% of it to products, what are you going to do still with the remaining 80% of the CO2? Depending on the portion of biogenic CO2 you have in that mixture, of course, there are new markets opening currently. If you're able to store that, then you'll be able to also trade the credits in the global markets. And that's one of the future revenue streams for emitters. In terms of infrastructure, storage and transport, there are only 2 options available for transport, I would say. And of course, the plants that are close to a harbor or port are at a very advantageous location. Maybe they can build their short pipeline to the harbor or create some kind of trucking scheme, logistics arrangement. But the ones that are inland, they are really depending on the railroad transport. And those also are going ahead still with the project development, because then they can make their own railway connection to a trunk line that is already existing. And that's also the sustainable way of moving the CO2. Pipelines, of course, are the probably best investments in this case. But utilization, I think we need to consider what is the impact of utilization in the big picture. And on that, I would say there are only probably 2 utilization cases that make sense. One is going for the methanol synthesis, where it can be used as a maritime shipping fuel. And the other one is the aviation fuel, because especially for the aviation case, there's no other alternative available. And we will need that CO2 to be utilized for that one. But other cases like making plastics from CO2 and things like that, I think we really need to question, is it worse?
Yeah, the life cycle analysis sort of of the whole process.
Okay, well, that's all we have time for in this inaugural episode of the World Cement Podcast. To hear the rest of our closing panel discussion from EnviroTech 2024, make sure to check out episode 2. Goodbye for now. Hello everyone, I just wanted to take a moment to remind you to register for World Cement. It's free of charge and gives you access to the latest issues of World Cement. Simply head over to worldcement.com, click the magazine tab and register today.